Yeah. All right. I'm going to take some time to learn how to use LaTeX. LaTeX is something that is used for writing technical documents like lab reports, journal articles, stuff like that. First thing I want to do is have you install it, which you've already done, right? Did everybody get it installed on Monday? Okay, so you've got texmaker installed. All right, so some terminology. We've got content of a paper versus formatting of a paper. And content is what your document says, and formatting is how it looks. And so we've talked about this in previous modules when we started using text editors. We saw that if you tried to open up like a Word document or a LibreOffice document in a text editor, there's a bunch of stuff in there that was more than just what your document said, because it has to keep track of what words should be bolded, how big are the margins supposed to be, all that information is in that document. And so a text processing program like Word or LibreOffice Writer, or whatever the Apple one is, Corey. No, the like Word document. Pages. They contain content and formatting together. Typesetting, when I talk about typesetting, LaTeX is a typesetter. Typesetting is taking a document and formatting it, right, for printing. So you want to get a document in a format that's ready to print. Markup means using special keywords to describe the structure of your document. Good afternoon, Tyler. So like HTML is the hypertext markup language. That's because HTML is a series of tags that you put in your document to say, make this a header, make this a section, make this the body, make this bold, make this italic. So you basically do your formatting with markup. Word processor like Microsoft Word or Pages or LibreOffice, these are programs that merge these two together, and they're often called WSIG, WYG. Probably hear that one a lot, right? So what you see is what you get type of editor. What you type in is exactly what it's going to look like when it prints, as long as everything goes okay. Although sometimes we've had, like in the labs, it's often common for students to try to print off their lab report and it doesn't look the same as it did in the editor that they were using. And then compile. LaTeX is basically like a source code compiler. It's almost like a C compiler. It takes LaTeX code and it turns it into a PDF. So instead of taking C source code and turning it into an executable, we're taking LaTeX source code and turning it into a PDF. All right, so why would we want to do this? First of all, it's very common in math and science, and if you can put legitimate LaTeX experience on your resume, that's something that stands out, that people look for. Because in almost every math or physics research lab, they're probably using LaTeX to write most of their papers, unless they've got people that have never used LaTeX, and then they're still using Microsoft Word. One nice thing about it is that you separate your content from your typesetting. So you just write your content and then you put commands in there that tell it how it should be organized. But then the LaTeX compiler is responsible for figuring out where your figures go, how to make the headers, how to number the headers, how to number the equations. That's a really nice one. You don't have to worry about numbering your equations. All of that's done automatically. How to reference the bibliography correctly. So that's a nice thing. You separate the content from the typesetting. You write your report in a plain text file, so you could use Nano or VI if you wanted. We're going to use an editor that sort of helps the process at first. Use markup to determine the section. So you identify this is a section with a command that says section, and then it generates a PDF. One of the primary motivations is the way that math looks. This isn't as bad as it used to be. Like the Microsoft Word math editor is better than it was in the past, but it used to be terrible. Here's an example of a paper that was, I think this was published in 2007, and this author used Microsoft Word for this paper in a journal proceedings. And you can tell that they used Microsoft Word because this is what the math typeset looks like. This is a paper that I wrote that is the exact same equation. Notation's a little bit different, but you can just see this one looks like it came out of a textbook, the right-hand side, right? The Does not look like it came out of a textbook. Even if you can't identify what it is that makes it look weird, you can tell that this looks weird. It's the font, it's the size of the integral symbol. It's, you know, a bunch of little things that you don't realize you expect to see math formatted in. And so this is how LaTeX by default formats any math. So any equations that you write are going to be formatted. They're going to look very nice. There's support for automatic cross references. So you can write an equation, reference that equation later on in your document. If the equation number changes, you do not have to do anything special. LaTeX will automatically update all of the equation numbers. So let's say you've got an equation that you write. Then it turns out you need an equation above that. So now the first equation becomes equation number 2. You do not have to go through your document and change all of the references to equation 1 to equation 2. That's done automatically. It's got support for automatic bibliography generation. All you have to do is cite the papers or the references that you want to put into your report, and LaTeX will automatically create the bibliography for one, so you don't have to worry about how to format it. And then it will automatically extract the numbers that needed to be placed into the document so that you can reference those references, right? So that you can cite those references. If you add references, all of the numbering is updated automatically. You don't have to worry about formatting bibliographies or getting the correct numbers in for your citations. That's all done. And because it's plain text, it can be edited with scripts. So you could write a Python program or a shell script to either edit or create LaTeX. Like if you wanted to, in this project that we're working on now, you're gonna write a shell script that analyzes the data and then creates a graph, like a PNG from using GNU plot, right? That same script could also automate the generation of a LaTeX document that would then create a PDF that had your data in it as a graph. You wouldn't have to open up anything. You wouldn't have to right click on anything. It would just all be done. So you can script with plain text, and it's very fun to use, especially if you like to program, because it's just like, it's like programming for your documents. So I know a lot of us don't like to program, but that's why I like doing it. Demotivation, reasons why you would not want to use LaTeX. Figures can be a little finicky. You basically can't just import in arbitrary formats. I mean, if you use PNGs, that's fine, but you can't just find some format of a picture that Joe Schmo created and then it automatically imports. You usually have to convert that to a supported format. You cannot just click and drag figures to desired positions, although depending on your experience, that might be a reason why you would not, or you would want to use it. If you've ever tried to get a Word document to anchor a figure to some place and then it always moves around and you can't figure out how to get it to stay. But LaTeX is responsible for where it's going to put the figure, so you don't even have control over it. And eventually you just take the position like wherever they say it should go, let's just accept that. You have to separate your content from your typesetting. So that's a reason why you would use it and a reason why you wouldn't use it. It is not, you can't just look at it and tell exactly what it's going to look like, right? The more you use, you can look at it and say, oh, this should be formatted in bold, but it's easy to make mistakes. So you can get bugs in your document essentially, and you don't get to see it until you compile it to look at it. The LaTeX compiler handles the formatting, which means if you have something that you want it to do, you kind of have to trick it into doing it, right? It's going to do something that it does by default, and then you have to convince it to do something if you don't want it to do what its default thing is. Sometimes it can be a pain, and it is absolutely impossible to decipher their error messages. So if a document's not compiling, it's really hard to figure out why. So it's best to compile often in little short bursts, like make a little change, compile, make a little change, compile. All right, here's an example. So this is LaTeX code on the left. This is what it looks like. This is a picture of the PDF that was created from that source code. So you can see things like use package input ENC, use package graphics. Here's a little thing that says section, first section. That's the markup stuff. So I tell LaTeX that I'm going to start a section and I want the title of that section to be first section. LaTeX generates this. How does it generate? How does it choose the fonts, the numbering to use, all that kind of stuff? That's all controlled by a style file. And so one of the nice things about separating content from formatting is that if you want to change the style, you basically just have to go up here and change the document class. So you could choose another style in which these would be Roman numerals, or they wouldn't be bolded, or the subsections would be labeled with A, B, C, D instead of numbers, right? So all that stuff's handled by a style file. You can find a style file and apply it to the same document. So you can compile it and make it look basically two different ways. I've got, for example, the title here. So title and example document, that's markup. I want the title of the document to be this. If my style includes the title at the top of the page centered, then that's what LaTeX is going to do. Author, date, all of that's the same. So this is what it looks like. This is what it's going to produce. That's what we're getting ready to use. All right, so let's start our first document. Open up texmaker. So go down here to the menu. You can do a search for texmaker, and you should see an icon pop up if you installed it.
So we're not doing this in the terminal.
No, we're not doing this in the terminal at first. We will. We'll see what's going on. So texmaker is a program, and what texmaker is doing is it's trying to make writing LaTeX documents a little bit simpler than it is if you just do it from the terminal. So it's going to have a lot of nice things. One of them is, like, this is my blank document. How do I start a LaTeX document? There's a lot of stuff that has to go into it. First, I start the document class. I need a begin document tag. I need an end document tag. texmaker has a wizard option. So if you go to quick start up here in the wizard menu, you can choose options, and then texmaker will create a template for you. So open up the quick start wizard. Document class, this is the type of document that we're going to make, like basically what is it going to look like. So the basic ones are article, report, letter, book. Beamer is a way of making presentations, so you can make slides. Let's do article. That one looks real sharp. And then you have options that you could choose. So for example, if you wanted it to be, where is, find like landscape, you could put a draft watermark on it if you wanted. One column versus two columns. So if you want your paper to be formatted in 2-column format, you just select this option, add that. So there's a lot of options here that you can pick from. Pick your font. This one we need to change. A4 paper is fine, but A4 paper doesn't print on any of our printers. So you want that to be letter paper. A4 paper is a size. Yeah. It's very close to letter paper, but it's slightly different. And typically the problem is if you send an A4 paper to a printer that doesn't have A4 paper, it will just not print it. It just sits there and spins. What's that?
Europe, it's A4. So
yeah. Yeah. Metric versus.
Yeah, basically. Versus A4.
Letter is 8.5 by 11 inches. A4 is actually A4. I used to not like it because it won't print, but it's actually pretty sweet. A0 paper is like poster sized. And the ratio of the long side to the short side is the square root of 2. If you fold it in half, the ratio of that long side to the new short side is square root of 2. And if you fold it in half, that's A1. You fold it in half again, that's A3. You fold it in half again, it's A4. So you fold a poster, I don't know how big it is.
1 to 3 to 4.
1, 2, 3, whatever the numbering is that is required to get there, Derek. Thank you. You fold it 4 times, and then you got a sheet of paper that's about letter size. And the nice thing is if you fold that in half, the ratio is the same. So apparently it's really easy to print pamphlets on a single piece of A4 paper because all you have to do is make the 4 pages you want in A4 ratio, and then it will exactly fit on halves of those pieces of paper. But this here is America, so we're letter paper users. And if Europe switches to letter paper, then we'll start using A4. Until that happens. Author, we can put the author in here. So go ahead and type your name.
Mr. Wolf.
Yes.
Mama.
Mr. Wolf and Mama Bear. Uh-huh. Nice.
I'm gonna type in Farsi. How about you?
You click
Farsi?
on the table package right there, and then click on Farsi.
Farsi, that's what Kayvon speaks, I believe, isn't it?
Yes.
Is it Farsi?
Type German.
I want to type in Arabic. I like that letter.
What's that?
Is that a Star Trek
Yeah,
language or what?
it's the,
It's
What they
Klingon
speak
or
on-
whatever.
what they speak on the planet all around.
then we got
They
some
speak Alderonian.
packages that you can select here. This is just going to create the, it's just going to put some include commands in. So LaTeX, like I said, is similar to compiling code to make a program. So you include libraries to say, oh, I want the ability to, add figures into my document. I want the ability to use special characters for my math. So the most common ones are going to be graphics package. So if that one's not clicked, click on that one. And AMS packages, those are very useful. Yes.
Is the geometry package like,
Make polygons.
Geometry package lets you set your margins. So you can control like how big you want your margins to be.
What is component package?
I have no idea.
Font.
KP fonts. It must be some special fonts that. All right, so
Those
click
are
OK.
16 characters.
There we go. This is what it types in for you. If you don't do this, you have to remember this,
No.
which you don't, you won't remember. So you go look it up somewhere. Basically what you do is you find an old file, you copy that to a new file, then you make edits to that file. I guarantee you, every LaTeX document that Jack writes today is a copy. It's like you could directly draw the lineage from his dissertation. So what he wrote in grad school, I guarantee you, has been copied to the current LaTeX documents that he's using now. It's stuff like this. Okay, I don't know what this package does, but I don't want to delete it, so I'm going to put a comment there. Percent signs are comments. So it's just full of all this stuff. A bunch of it commented out. No idea how it works.
Why did you learn things?
He does. I told you he does the same thing with computer programming languages, right? He's written the most code of anyone I know that doesn't know how to program, and he's written lots of programs, still has no idea how to program.
are these the one that uses all the stars in Java?
Yeah. All right. So begin document and end document. The stuff in between that is what's going to be in your document. Right? The stuff before that's called the preamble. The preamble has got stuff like document class. That's got to be the first line. That's telling it what type of style to use for it, and if there's any options. So I've got 2 column selected here. That's gonna make a 2 column paper. And then use packages. These use package commands. These are saying use the AMS math package, which is basically like a library. What that does is it basically brings in new commands that will do certain things for you. So let's just make sure that this works. What do we absolutely have to write in our first experience with the programming language?
Hello world.
Hello world. Let's say it with enthusiasm.
Bold it just to really be enthusiastic.
All caps.
Are there variables in LaTeX?
Yes, there are, but they're called macros.
Do they interpret like binary text and everything?
I have no idea. I have no idea. All right, so to turn this into a PDF, what we do is we go up here to this button right here, this arrow next to quick build. And you hit that button, and it's going to complain that we haven't saved it. So we got to save it first. All right, so need to save it. So go up here to File, click on Save. Here's what I suggest you do. Every new document that you're going to write should be in its own folder, because it's not going to be a single file. It's not like it's going to be one Word document, and then you can put a bunch of Word documents into the same directory. So what you need to do is you need to create a new directory for every document that you're going to make, because there's going to be a bunch of files associated with that document. And you should keep these in a place that's common. So I'm going to go into documents, and I'm just going to use this documents folder as the place for my documents. Now I'm going to create a folder in here, and I'll name this example. Let's do Hello World. So I create that, and now I'm going to name my LaTeX file. It's very common to use main. I typically use something that is more descriptive, so hello world. If this is something that you're going to be giving to somebody, then it's a good idea to say something like, you know, put your last name in there, so that whoever it is you're sending it to, if they're expecting documents from other people, they don't get 10 documents all named Untitled 1 or presentation or report, right? It's the exact same thing over and over and over again. So I'm going to do Clark, hello world, save. Now I'm ready to quick build. Hit the quick build, and my document appears over here. So this isn't exactly what you see is what you get, but this gives you a live, well, not a live, you have to quick build it every time. It gives you a quick view of what the document looks like. So let me zoom in here. Actually, what does this one do? Fit width. There we go. Hello world. Yep.
What opens in a different window? How do I get to it?
I don't know. To be honest with you, I don't know how to use texmaker, because I don't use texmaker. We just use it here so that we can use the templates, not have to try to memorize all of these LaTeX commands right off the bat. But in terms of configuring texmaker, I have very little experience with it. There's an options menu that says configure texmaker. Tons of stuff in there.
What do you press?
This arrow here next to quick build.
Yeah, mine errors.
Can you decipher the error message? It's impossible.
PDF LaTeX dash syntax equals 1, interaction equals nonstop mode. There's the
Did you
dot
have an
text.
end document out there?
Yeah, did you put it in between the hello world or the begin and end document?
Yeah.
Did you accidentally delete a curly bracket?
No.
Did you type this in literally the same way that I did? Okay. You tell me if I walk over there, I'm going to find the exact same thing, but I have all the.
Come on, get adventurous.
You didn't put Arabic in there or Farsi or something like that, right?
Quick build?
I get emphasis.
Maybe you don't have something.
You're opening another window too? Yes. Or do you hit do? Yeah.
Okay, so what happens when you have a suit there?
Yeah, hit that. I don't know.
What's the difference between emphasis and
That's what I hit.
So let's check to see if you actually have.
Patrick, did you say yours opened it up in like a new window?
Yeah, let's see that you've
Did you
got.
fix it somehow? Or are you just dealing with
Let's
it?
see that you've got LaTeX installed. So type
Or is
LaTeX,
it the same thing? No, mine's not. Courses.
do Control D. Type PDF LaTeX.
It's exactly like what
LaTeX.
you put a smiley face.
Okay, so Control D. Go back.
The new window coming
Maybe.
Yeah, you don't know.
Sure.
We'll laugh.
Oh.
Maybe it's because your screen's not big enough.
Oh, do I have to?
Yeah,
Like,
It is
Why?
just because it's such a tiny screen.
It's going to put that, when you save it, it'll put an extension on there. You can't have multiple dots in your file names. That's a good one. Very subtle. Very
What?
subtle. Can't put dots in your file names. The LaTeX compiler expects one dot, and everything after the dot is the extension.
Why does it open in different?
Oh, I don't know. I could replay the video when Patrick asked if. I don't know how to configure it.
Stop.
I'm guessing it's somewhere in the configure texmaker, but
It's got to be in the configure textmaker. We configure it.
I just don't
What's
know
the
why you
difference
guys don't
between
do exactly
emphasis
like
and
I did
italics?
it. I typed it in literally the same way.
Listen.
it worked, and I got it.
They're not
Found it.
visually distinct.
Patrick's got it. Think a little star. You ready?
Look at that smile. Patrick's so happy when he finds something.
Options. Yeah.
Configure texmaker,
Quick build.
and then on the right side underneath PDF viewer, there's a box that says embed. Check that.
Commands, quick build, editor. Where?
Commands under PDF. viewer,
Okay.
Where it says embed. Oh, there's that check mark.
PDF viewer, embed right there.
Nice job, Pat.
All right, now where is the title?
Haven't put it in yet.
I've got author and title right here, right?
Yeah, dude, my title is the paper of the year. So.
You have really high hopes for yourself.
A lot, the high bar.
Yeah.
All right, so in order to get it in there, we have to explicitly say, make the title and put it in here. So there's a make title command.
Do we have to do the slashes? In
Yeah.
the lines? Yes.
Yes, the slashes.
Okay.
Yeah. So the beginning of LaTeX commands start with a, is this a forward slash or a backward slash?
You could make it a slash.
That's what I got. Yeah. I'm showing that one of the nice things about texmaker is it does command completion. So it'll give you, if you know how a command starts, you can get it typed out. How about that? Make tie. And it'll come up with a list of possible options. So for example, make, there's a make index and a make title. Either one of those I could be wanting. And then I think, yeah, you click on it, it'll finish it. If you hit tab, so if it's already highlighted on the one that you want, you can hit tab and it'll auto-complete it. So now you do another quick build. And there is title.
It's like sending an email to yourself.
What's that?
Oh, I wonder what it's gonna look like.
Yeah, exactly. Now notice it automatically put today's date in there, so you don't have to remember what date it is. If you need to change the date, like for example, you don't want it to look like you wrote your report the day it was due. Not that anybody here would do that. There's a date command, and that will be put in. So by default, the date in the dates section is going to be today's date, but you can put whatever you want in.
I really need to just set that in the wizard to always generate that.
Let's make it look like 10 days ago, right? So it doesn't matter when you turn it in, you're always doing it early. That looks good.
Yeah, I was always told that you're supposed to put the date that it was due on there. Yeah, not the date that you do it.
All right, sure.
Those aren't distinct for me.
Yeah. What's the difference?
Yeah.
What are you talking about?
That is why that's.
Probably.
So, as I've mentioned, texmaker's got a lot of useful features. One of them is that wizard, so you don't have to remember how to start up a document, and you don't have to make copies of your 15-year-old dissertation to start any new document. It does command completion, so that's nice. It's got a lot of, so not even the wizard, but there's like some templates for creating tables, stuff like that. So it's got a lot of nice features in there. I use VI and make files that, so it basically takes a long time before you remember all of the commands well enough to not have to constantly be looking them up. All right, so let's do some more stuff. The basic, if you look at the commands in your document, the basic format is all commands start with a slash. So it's slash command name. The command might take an argument. If it takes an argument, it's going to be between curly brackets. So some of those commands take arguments and they're in between curly brackets. Some commands take optional arguments. And if they are optional, they're going to be in square brackets. So if we look at the document that we have, make title is a command that takes no arguments. That tells it to actually generate the title and put it into the document. The date command is a command that takes an argument. So whatever you put in between those curly brackets is what's going to be set for the date. The document class command takes an argument, which is article, but it also takes options, which are these things here between the square brackets. Now you can't tell. Yes?
So why can you put the date? So anything you put before begin document, is that going to be centered? You know what I mean?
No. Well, anything that goes into like this stuff up here, This is part of the title, which is the article class style. So that's going to be centered. Yeah. So let's just put in a bunch of stuff here so we can check to see that it actually is. I believe this is what it is, right?
Yes.
All right, let's check to see that this is 2-column. Yeah, it's 2-column. I could change the article to report, and it's going to change the style. So now I get a title page, right? And then my document is here. Typically journals, like if you're going to submit an article to a journal, if they have Latex support, they have a document class that you use, and then it formats your paper in the format that the journal requires automatically. All right, let's see what else we can do. We've already set the title. We've already set the author. Let's use math mode because that's the thing that is most useful for LaTeX. It's the thing that usually gets people in our situation using LaTeX. Math is identified with $signs. So commands that are going to be translated into math need to be inside of $signs. Some of you have already recognized that the version number for LaTeX is pi to some number of decimals. The person who wrote tech, his name was Donald Knuth. I don't know if he's still alive or not. His name's Donald Knuth, and he does sort of strange things like that, funny stuff like that. So the version numbering on LaTeX is every time a new version comes out, another digit of pi gets added. The number itself doesn't change. It just goes to more precision. So he used $signs to specify math because at the time, formatting math was expensive. Right? So this is like money in the pocket here. So let's see. Let's do the equation for a line.
According to he's still alive.
Is he still alive?
Yeah, 79 years old.
Did you guys hear what happened in Solid State with Dr. Deo?
No.
So Lydia, Brett, Bergie, Rodrigo, and maybe a couple other people in that class. So anyways, he hands out this paper and somehow it comes up like, who's the author of this paper? And Dave was like, oh, he's a very famous physicist. You know, he's done a lot of work in Solid State. And they're like, well, how old is he? Is he still alive? Dave was like, yes, he's still alive. I would have heard if he had died. Lydia looked it up. He had died that day. She's like sitting there reading it. She's like, it says here that he died March 29, 17. She just got really pale. So hopefully Donald Knuth made it through this one.
You
All right.
just see it, all of a sudden it changes.
Yeah, it's
I'm just sitting here just
like one of those texting apps.
all
that
of
says,
a sudden column of death. I'll refresh the page. Nope, still alive.
College students asking about.
Yeah.
all right, so I put this in $signs, build it, and here's my equation, and you can see that the font is different, right? So it uses a font that math looks good at. So that's math mode. If you wanted to have an equation on its own line, for one, notice that all of these returns, like I've got hello world on a single line, all of that's completely ignored. LaTeX takes it and turns it into a single paragraph. If I want an equation to be on its own line, I use double $signs. So let's do sine of omega t. So y of t is equal to sine of omega t. Hit build. That equation gets its own line centered.
Why did you put the slashes before the function?
Because that will format it. See, if you look at this, let me just copy and paste. If I remove that, I'm going to get the symbols SIN formatted as if they were variables. And if you look at like your physics textbook or your math textbook, whenever sine is written, it's formatted in a different font than the other symbols.
So same thing with like omega. All your Greek letters.
Yeah, so all your Greek letters have commands for them, right? So slash omega is lowercase omega. Slash capital omega is going to be uppercase omega. There's delta, epsilon. I mean, they're all there. The ones that you use most often are going to be alpha, beta, gamma, delta, epsilon, omega, and lambda. Probably the ones that get used most often.
How can you number equations?
So we're going to have to use the equation environment. Let's do that right now. So I've got, actually, let's add a section, and then we'll add an equation under that section. So let's make this top part here the introduction. So to start a section, it's the section command. So there it is, command completing for me. I hit tab, it inserts it. And then the name of the section goes in as the argument, introduction. Let's make another section down here called methods. I'm going to hit compile to make sure I haven't introduced any syntax errors. All right, so I've got introduction section and a methods section. Got that, Joey?
Oh, which that there's a button that will automatically give you $signs on the left-hand corner. It doesn't format correctly if you hit it twice. It'll just return an error.
Somebody did an error writing something, trying to get a new line, and then opened up this console where they can't get it to close.
Good luck with that. Have you tried turning it off and turning it on again?
Quit breaking all your stuff, man.
Can you right click on the window and click quit? No? Can you close texmaker and reopen it? All right, so environments are things that sort of change the, well, they change the environment, right? So this begin document and end document, those are those indicate where the document environment is. So everything outside of that is not part of the document. There's an equation environment. So I do begin equation, which is right there. Nice thing about texmaker is that it will, for these environments, it automatically closes it for you, so you don't have to type end equation or end document. And now, if I type an equation in here, this is going to be numbered. Actually, let's do y of t equals. Subscripts are a underscore. So y0 plus v0 times t plus fractions are frac command. 1, 2. Acceleration t. Superscripts are caret.
What? Is that Y0?
Y subscript 0. So there's a underscore. Yeah, kind of bleached. Now I get an equation number. Let's do y.
You don't need $signs for this.
Nope. Integral signs are /int. We're going to integrate velocity as a function of time. Looks like this. So my equations are numbered automatically. if I change the order here, say I decide to reorganize my paper. My equations are automatically renumbered, which is very nice. Very nice. I put another one in here. So let's say I decide I need another equation in between these.
So pretty.
Then that third equation gets renumbered to 3.
How'd you create a specific integral instead of a general integral?
You mean like a
Like one that has
one that
bounds?
has definite limits? You subscript and superscript the int function here, or the int command. So from 0 to infinity, for example.
You
Would
have
be
to
that.
do the subscript first.
No, you can do whatever order you want.
That's tricky.
If you want, like you can see where the limits here are placed. They're placed to the right of the integral sign. If you want that to be above and below, then you put the limits command right after the integral sign, and it'll put it above and below the integral sign.
This is really nice.
Yeah, I mean, other than it being impossible to read, you having to write out a bunch of stuff. It turns out it doesn't take very long. You know, you've got a set of commands that you use quite often. That becomes much faster than trying to use the equation editor in some software and build these equations.
Takes forever.
Yeah, it takes forever. That's why we let people just handwrite math in their lab reports. What's that?
I'm still a typer and I still.
You didn't know that?
That's what I've done with all of my lab reports.
I'm like the only person in my class that even bothers to do all my equations in the paper. Everyone else just leaves spots and they'll write it in by hand.
Joey takes care of business.
Oh, Joey, do you make your charts too?
I mean, it takes me 5 hours just to type something, but I do it. I like the way.
Doesn't matter how long it takes. That's the right way to do it.
Were you in my class?
I've been in almost every one of your classes.
No, like
I wasn't in your lab.
Yeah.
I don't think.
Because like even Jared didn't bother. I thought it was really weird.
All right, a couple more things. So we just added an equation using the equation environment. If you wanted to use the equation environment and not put a label on it, which there would be reasons that there'd be reasons to do this that we wouldn't really be aware of currently, but the equation environment allows some more fancy alignment than just using the double dollar sign. For example, if you've got multiple equations, you can get them to align on the equal sign. And if you wanted to do that without numbering it, then there's a couple of ways to achieve that. One is to just put at the end of the line a no number command. The other way is to put a star after equation in the environment here.
Well, that's why I kept asking if I wanted to do that.
Yeah, so there's usually starred versions of these environments that will strip off whatever the numbering is going to be. So now I just have one equation that's numbered 1 automatically for me. The other 2 are formatted exactly as they would be if they had a number, but they're not numbered. Let's say I wanted to reference an equation, because this is where it gets really useful. How do I get something that will then, like I can reference equation 1 and have it insert equation 1 for me? There's 2 things I have to do. The first thing I have to do is label the equation that I want to reference. I need some way of saying this is the equation that I want to use. And so inside the equation environment, I need to add a label command. And then this is going to be a string that I use to reference that equation later on in the document. You can use whatever you want. I'm not sure that you can have spaces here. So it needs to be, usually these are very short and terse labels. I use this format. For any labels that are going to be for an equation, I use EQ : because the label command can be used for tables and figures as well. So EQ : let's say this is kinematic. Now, how do you spell kinematic? Is it Kinematic?
Yeah. Kindmatic.
Kindmatic. Now that by itself isn't going to do anything. All right, hit enter. All right, quick run it. I still have the same thing, but now I can reference that equation. The kinematic equation in, and to reference it, I use the ref command, and then I use that label that I just created. So, and the nice thing is that texmaker knows all of these labels that I've created, so I can just click on that. It's only for constant acceleration. Hit build. It says equation 1 is only for constant acceleration. Let's say, so let me take off the no number in that first equation. Now that's equation 1. I do a quick build. I see that the equations have been renumbered, but the reference is incorrect. I need to do a quick build again. And now it's correct. So when LaTeX goes through your document, it has to create these labels. The first thing it has to do is go through and figure out what the equation numbers are for everything. So that's one pass. And then if I reference stuff like this, it has to go back through and replace all of the references with the numbers that it generated. So you always have to run it twice if you have references. 1, to get the reference numbers, and 2, to get those numbers into the places where they're actually referenced. So now this is referencing that equation. It doesn't matter if that equation moves around in the document. The numbering is going to be automatically taken care of for me. Yes, Derek?
When you run this, does it save the file to its original location each time, like other compilers do?
Oh, you mean like the PDF?
Yeah, like, no, I mean, the file in what you're writing.
Yeah, well, I mean, we chose a place to save that, right?
Yeah.
And so it's saving it to that place.
Okay.
And we can go look at that place and see what's being created. So let's open up a terminal. I'm going to go into documents. There's my hello world folder that I created. And here is the file that I'm actually editing. This is some sort of file that was created by texmaker. This auxiliary file is something that is used by LaTeX. This log file is used by LaTeX. This is the PDF that gets created. So I could cat my text file, and this is the plain text file that texmaker is writing every time I hit the quick build. Let's see what's in the auxiliary file. The auxiliary file has got information. Here's like metadata. This is a little command here that LaTeX uses to figure out what number should be inserted for any references that reference equation or the label EQ kinematic. And here's the same thing for the methods section and the introduction section. So this auxiliary file is what gets created after the first pass. Then it has to rerun, look at what's in the auxiliary file to figure out what numbers to put into the equation references. Same thing happens with bibliography. If you have a set of references that you're going to cite in your bibliography, LaTeX will run through it, generate a list of references that need to have numbers for them, and then plug those numbers in for you. What's that?
I'm looking at my log and it says however many words out of 5 million.
Oh, so 5 million is its
Memory.
memory limit, huh?
Words and some words.
I have no idea. I have no idea. All right, we're going to pick this up on Monday. You're free to use this over the weekend. Rewrite all of your lab reports using LaTeX over the weekend, Corey.
If I can read my word.
I think that I'm having to write a paper for my gen ed class. I think I'm going to do it